In this video, we're going to be studying one-sided limits. All right, so we're going to be looking at the objective. What is the objective for this video? Well, we want to find one-sided limits if I give you the graphical function, if I give you the graph, and finding one-sided limits if I give you a piecewise function. In other words, it is a function that's made up of pieces. So let's go ahead and let's look at what definition. There are two sides of any value. So if I choose any number, let me go to the next slide right here. I have a number line. It doesn't matter which value I pick. If I pick the number 2, there's two sides to that, the left side and the right side. If I had chosen the number -5, there's the left side and the right side. So any value that I pick on this number line, there will be two sides to that, the left side and the right side. All right. To distinguish, we have to be able to correctly identify which side. So from now on, we're going to be using the limit of f of x as x approaches c with a little minus. If you see this little minus right here, that means that will be the left side. This is the notation that we're going to be using for the left side. Now, if you see a little plus to the upper right hand side of the x value down here at the bottom, that means that this will be the right side. That means that we're coming from the right side. All right, so let's go ahead and go back to the number line. And in this notation here, it says find the limit of f of x as x approaches 0 from the left. So this is my 0 right here, and I'm coming from the left. So that means that I'm going this way. I'm going 0 until I approach this x value. This one over here, though, this one is saying you're approaching the function, all right, but you're approaching it at x equals 0, but from the right side. So that means that we're coming from the right. We're coming from the right until we get to this x value. So we want to get to this value right here at 0. All right. So let's go ahead and look at definition. Let c be a real number on the x-axis. The function f is continuous at c if the limit is equal to the defined point at x equals c. All right, so some of you are going to look at that and says, well, I don't understand what you're talking about. So let me go ahead and give you a little visual here. I'm going to draw a visual here. All right, now right off the bat, you can look at that value and you can say that is not continuous at c. Why? There's a hole, sir. There's a hole right there. There's a hole. So it is not continuous. Let's pretend that I have a dot right above that hole. So my limit is going to be approaching this side, and my limit is going to be approaching this side. So I have my left side, my right side. So both of them will be approaching this hole, but the dot is defined up here. So if it's defined up there and it is not the same at the limit value, we're going to say that it is not continuous. All right. The function f is right continuous at c, or continuous from the right, if the limit from the right side is equal to f of c, and it's going to be left continuous if the limit of f of x as x approaches c with a minus, there's supposed to be a little minus there, is equal to f of c. So if they approach the dot, so what this is saying is that if I come to the right and it's going to be approaching the dot, then we say that it is right continuous. If it's coming from the left and it approaches the dot, we're going to say that it is left continuous. If both of them approach the dot, then we say that it is continuous. All right. So let's go ahead and look at some examples here of the graphical part and then the piecewise functions. So in this case, what I like to do is I like to tell my students, all right, so what is the limiting value? What are we trying to approach? The x at x equals 2. So right here is 2. So what I tell them to do is I want you to do an asymptote, an imaginary line. It doesn't exist on the graph. We're just making it exist. Okay. Now what I like to do is I like to tell my students, all right, so this right here is telling me to approach from the left. So I get on the path and I'm following my path and I'm reading. Remember, you always read from left to right. Well, in this case, but in the other case you're not. So as I'm coming from the left, it's going to be approaching the last dot before I grab to that green line, arrive at the green line, is going to be that dot. And what is that dot located? What's the y value? Remember on the last video, A limit is the y-coordinate. What's the y-coordinate when I reach that green line? Well, we're going to say that the limit of f of x as x approaches 2 from the left is going to be 2. It has a y-coordinate of 2. Now let's look at the right side. On the right side, remember I'm approaching this 2 here from the right side. So I'm on my path and I'm reading it from right to left now because we're trying to arrive at 2 from the right side. So as I'm coming from the right side, I'm going to hit that dot when I arrive at that asymptote that I drew. So what is the y-coordinate? What's the y-coordinate when I approach 2 from the right side? So when I look at from the right side, it's going to be approaching this y-coordinate, and that y-coordinate is located at -1. All right, so we just found out the limit of the left, and we found the limit of the right side. Okay, let's do another example. All right, okay, now this limit is asking -1 from the left and -1 from the right. So I'm going to draw an imaginary asymptote here. All right, now I'm going to take from the left side, this is from the left side, so I'm going to say the limit, what's the limit of f of x as x approaches -1 from the left side. So as I come from the left side, I'm going to keep following my path. I have to be on the path. When I'm coming on the path, oops, it's going to hit that. I hit the green line, but where did I hit that green line? I hit it at, the y-coordinate is 4. Now let's follow the path from the right side. So let's find the limit of f of x as x approaches -1 from the right side. So I get on my path and I follow it. I'm trying to get to -1 from the right side. So what happens? What is my y-coordinate going to be when I come from the right side? It's going to be 1. Now, for a function to be continuous, remember let's go back to the statement up here. In order for it to be continuous, the limit, which is both sides, has to equal to the dot. Well, right here, I'm noticing that this value and this value are different, so we're going to say that it is not continuous. Now, some of you are going to say, sir, I could have looked at the graph and I could have said it was not continuous. Man, I commend you. But now you can actually justify it that it's not continuous because the left-hand limit and the right-hand limit are not the same. The same can be said of this one. This is not continuous. There's a jump discontinuity at -1 because the left-hand limit and the right-hand limit are different values. Now let's look at piecewise functions. All right, let's look at this first piecewise function. And what you need to understand is on a piecewise function, this part tells me that I'm going to use this graph when I'm coming from the left. And this is telling me to use this graph, that graph, when I'm coming from the right. That's it. All right, so I'm going to have this. This is telling me to do 0 from the left. So if I want let me change my color. If I'm doing the limit of f of x as x approaches 0 from the left, I'm going to be using the top function. So that means I'm going to be using -x plus 3, and I substitute my value, and I'm going to get -0 plus 3, and that's going to give me 3. Now let's do the limit from the right side. What happens when I'm coming from the right side? I use the bottom piece. So that means that the limit of f of x as x approaches 0 from the right side, that means that I'm going to have 2x plus 5. That's my function that I have to use. So it's going to be 2 times 0 plus 5. That's going to give me 0 plus 5, and that's going to give me 5. Now, is it continuous? Well, this guy, the left limit value is 3, and the right value is 5, so it is not continuous. This is not a continuous piecewise function. All right. Let's try the next one. Let's try a trigonometric function here. All right. So that means that all I'm going to do is I'm going to take my pi, plug it in here, and I'm going to take. Oops. Let me undo that. I'm using the wrong color. I like to use different colors. Let's not change it up. So when I'm trying to find from the left, I'm going to use the upper piece, and when I'm trying to find the right-hand limit, I'm going to be using the bottom piece. So here we go. And then when I plug it in, I'm going to get, the limit of f of x as x approaches pi from the left is going to be negative sine of pi. And somebody says, sir, I forgot what sine of pi is. So I'm just going to say make a very simple unit circle. All right, and I'm looking for this coordinate. Remember, it's going to be 2 pi all the way around. Pi is halfway. So that coordinate right there is going to be -1 comma 0, and we got cosine and sine. So that means that that's going to give me -0. So it's going to give me 0. So that means that it's going to approach a y coordinate of 0. Now let's look at from the right side. What is the limit of my function, my piecewise function, as x approaches pi from the right side? That means I'm going to insert the pi in there. So I'm going to plug in pi plus 2. Oh, and that's it. That's my answer. So this is an accurate answer. So we're going to leave it as is. Now, please don't give me 3.14159 dot 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 plus 2 is going to be 5.14159, etc. Just leave it as is. All right. Let's try one more. All right. Mr. Quintana, I want to find the limit of my function as x approaches -2. So let me go ahead and rewrite it here. The limit of f of x as x approaches -2 from the left. That means that I'm going to use the upper piece. And this is an interesting piece. This is why I threw this one in here. So when I plug in a -2 in there, I'm going to end up with 1 over 0. And from previous classes, I know that this is an asymptote. There's an asymptote at -2. So if I had an asymptote at -2, here's -1, -2. For those of you that are visual learners, as I come from the left, my graph has two choices. It's either going to go up or it's going to go down. So my answer is going to be either -infinity or positive infinity. So the question is, which one is the correct one? Which one do I choose? So what you're going to do is you're going to pick a number close to -2. Let me draw a number line. Here's -2, and I'm going to pick a number to the left side. So I'm going to substitute 1 over -2.001 plus 2. Now, the number, you could have plugged in -2.1, you could have plugged in -2.00001, more complicated. But remember, our choices are very simple. It's either going to be infinity or -infinity. So what you're going to do for me is you're going to evaluate, but you only care about the sign. So -2.001 plus 2 is going to be negative. 1 divided by a negative is going to give me negative. So my answer will be -infinity. So that means that my picture is actually going to be which one? It's the one that goes down. So I can take my eraser, oops, and I can erase this piece right there. All right. So now, what about the right side? All right, let's find the limit of f of x as x approaches -2 from the right side. Well, I picked the bottom one. All right. So what about this one? We just substitute, and we're going to say -2 plus 2. That's going to give me 0, and I'm done. All right. So again, we're going to say that this function is not continuous at -2 because the limit from the left is not the same as the limit from the right. Okay. Now, to throw things off, I might make we can complicate it by giving you 3 functions: x plus 2. Use that one when x is less than 1, -1. We can say x squared minus 7 when x is between -1 and 3. And then I can say use the square root of x plus 5 when x is bigger than or equal to 3. Now, in this piecewise function, though, it can get a little complicated. All right, so I can ask the limit, the right hand limit and the left hand from -1, or I can ask the right hand limit or the left hand limit of 3. All right. So the question that you always have to do. So let me go ahead and do one. The limit of f of x as x approaches 3 from the left. Okay. So whenever you look at this value, you look at 3. So this one doesn't have a 3. So this piece is irrelevant for me. Okay. So I really don't need this piece right here. So what I really need is that this one has a 3 and this one has a 3. So I'm talking about these two pieces. So when I'm looking for 3 from the left, that means that I'm going to be using, remember the left one? I use the one on top. So that means it's going to be 3 squared minus 7. That's going to be 9 minus 7, which is 2. Now, if I had said, find me the limit of f of x as x approaches 3 from the right, then I'm going to be using the bottom one. So it's going to be the square root of 3 plus 5. That's going to be the square root of 8. And that's my right hand limit. And again, this function is not continuous at 3. All right. Now, if I had given you -1 from the left, if I had given that function, then we use this one. If I had wanted the limit of the function as x approaches -1 from the right, I would use this one. All right, and that concludes our video.